hands up, and let's review a couple of major ideas. Number one, I'm going to reveal the graph. Number two, I'm going to get some responses. Number three, I'm going to get some responses, and then we're going to go back to number one. Okay? So here we go. Number one, here's what the graph looked like. That is the graph. And you can tell if you did it correctly by looking at two specific locations. If your graph crosses the y-axis at 3 and it crosses the x-axis at 4.5, then you have the correct graph. And of course, should have arrows on the ends indicating that it goes on and on forever. We'll come back to number one in a couple of minutes. Number two, what's the solution? We got Alex, David, and then Gary. And Alex, what'd you get? Okay? X equals -2. What about number three? What does that come out to? We'll start with Kaylee, Yadesh, and then we'll go to Loretta. Okay? All three of you think y equals 11? Y equals 11. Let's focus on numbers 2 and 3 for a moment. Give me a thumbs up if you got both of those questions correct. Thumbs up if you got both of those correct. Good. Put your thumbs down. Now let's go back to number 1. If you had this graph, could have been done a whole bunch of different ways. In fact, today's lesson, you're going to learn a new way to graph that. But up until today, the only method you know is to make a table. So the question is, what table did you make? Well, I made your life kind of easy because I put y equals, so that makes your life easier. But that fraction might have thrown you off unless you've been paying attention for the past 2 weeks. If you've been paying attention for the past 2 weeks, then you made this table. This table makes your life very easy. Because the original equation has a -2/3 and the denominator is 3, if you pick inputs that are all multiples of 3, that will make the outputs come out very nicely. It required some work, but it makes it come out nicely. Now, if you did do that and you had trouble with this, here's why. You're struggling with computation. I've said that before, and I realized earlier today that I don't know if all my students know what I mean when I say you are struggling with computation. What's computation? Can someone give me an example of computation? Because I'm saying you're struggling with it, and you have no idea what I'm talking about. Kayla, can you give me an example of computation?
Not understanding something.
That's an example of not understanding something. I'm asking for an example of computation.
So computation kind of like comprehend.
So you're thinking of a different word. You're thinking of comprehension. I'm using the word computation. Comprehension, computation, that sounds similar, totally different. Computation. 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 Gary?
Like to get a solution of or something.
Give me an example.
Like 2 + 2 = 4.
2 + 2 is 4. That's computation. Beautiful example. Outstanding. Give me another example of computation. Give me another example. Cheyenne? 38 times a squared. Computation. Give me another example of computation. Tristan? 0 + 0. Computation. Give me another example of computation. David? 1 + 1. Computation. So when I say you are messing up the computation, here's what I'm saying. I'm saying you're super high level in Algebra 1 honors, doing well with algebra, and you're messing up computation. Computation, you learn first, right? Right? So it's kind of like when you, I don't know, playing a sport and you're awesome at baseball and you can hit every pitch, but then when you go to catch the ball, you just, someone throws the ball and you just drop it. So, you're doing the advanced skill, but then the basic skill you're messing up. That's not really okay. You're supposed to have mastered the basic skill before you do the advanced skill. So when I say, great job with the algebra, but you messed up the computation, what I'm saying is, you messed up. Because you're doing awesome with the high-level stuff, but you messed up the simple stuff. So, here's where anyone who got this wrong, if you made these choices and you got this wrong, it's because you do not know how to do this. Negative 2/3 times negative 3 plus 3. And you're supposed to have mastered that. So give me a thumbs up if you know how to do this. Honestly. Good. Yasmin, what do you do? Okay, but you made your life miserable because look what happens when you do negative 2 divided by 3. 2 divided by 3 comes out to a repeating decimal. And then watch what happens when you multiply it times 3. Well, in my calculator it came out to 2, luckily, but in your calculator it probably didn't. Probably came out to 1.999999. And then you go, oh, I don't know what to do. But the problem is that you made your life more difficult and you were not paying attention to your basic skills. So you are supposed to have no trouble with this because negative 2/3 times negative 3 is that. Everyone pay close attention because I had a bunch of thumbs up, called on one of them, and they don't know how to do it. Negative 2 times negative 3 is 6. 3 times 1 is 3. 6 divided by 3 is 2. Negative 2/3 times negative 3 comes out to 2. So that's 2 plus 3 equals 5. You're not supposed to have any difficulty with that at this point. So what do I mean by that? What is Mr. Goud saying? You're not supposed to have any difficulty, but you do have difficulty. Now what? Should I spend the rest of the day doing practice questions about that? I don't know. You need it, but the problem is that you're in Algebra 1 Honors. You're not in 6th grade math. If you're in 6th grade math, then I spend a whole day on this. You're in Algebra 1 Honors, 9th grade honors class. I spend no time on this, which guess what that means? You have to do something about it. You have to do something about it outside of this classroom. Now, I do have worksheets on this, and if I am noticing that a large group of my students are messing this up, then I'll invite you to my care class and we'll do some practice for a couple weeks to address the issue. But I did that last year, and what I found was it actually didn't really help because somehow students didn't retain it from that practice. So I'm not sure what has to happen, but something has to happen because you have to be able to do this no matter what. Yes? I can't hear you. You said the 6? Let me see. Yeah. Let's see. 2, 2, 2. Yep, you're right. That's a mistake. Thank you for pointing that out. That's supposed to be a -1. So I'm not sure what I did, but clearly I made a mistake. So right there is supposed to be a -1. And Michael, thank you very much. Remind me to add a bonus point on your slip for you for catching that mistake. You're the first person to catch that, even though I've done this with 2 classes already. So that's very good. Okay? So, any comments, questions about graphing, doing the table, computation, solving two equations. Any questions? All right, let's hit the pause button. And staplers, I thought were going around. Really going around? Staplers are going around. You should have your score already. If you don't, go ahead and calculate your score. But I think I may have confused some people because I started calling the homework questions points, and then the slip also has points. So I think I might have confused you. So I apologize for that. The homework questions I'm calling points, but that's separate from the slip. It still works exactly the same. Can I borrow yours for a second? The homework points, you put how many points you earned on the assignment out of the total number of points, still find the percent and still circle the number of points on the slip, and then calculate your overall points by adding these up. So I apologize. I realize now, with the help of some of you guys, that maybe I shouldn't be calling them points. Maybe I should call it something else. I apologize for that. But go ahead and staple your work together. I'm going to get your scores from you in a moment. Yes, Caleb. Mm-hmm. In the meantime, here are today's notes you can get started on. In fact, remember, you don't write every word, and this is not an essay like you're doing with Ms. Ebanks. This is note-taking. Short words, abbreviations, leave out words that don't have a lot of meaning, like the and . Yes, I'm sorry, Michael. All right, when I call out your name, you tell me your score. Cheyenne. Tristan.
8.
Catalina.
7.
Chanel. Amir.
7.
Marcus. Gary.
Don't have it.
Laurel. David. Yasmin. Laurie. Caleb. Haley. Yadesh.
Second.
Which one is it? Amani.
7.
Alex.
6.
Adriana.
I didn't do it.
Michael. Jesse. Isabella.
7.
And Keisha Faye. And Paige.
7.
So don't worry if you're not done. This is going to all come back in a moment. So, of course, you already titled today's lesson 4-2, and the title is Using Intercepts. So you're going to learn what an intercept is today and how it can benefit you. From today's warm-up, we reviewed how to graph an equation. You know of one way to graph an equation. You make a table. Today you're going to learn your second method for graphing. Second method. By the end of the chapter, you will know 3 or 4 different methods for graphing. Why do you need multiple methods? You're going to learn as you go along. But again, you're going to learn the second method. And here's the thing. The second method is much more efficient than the first one. And so once you learn the second method, you will not use the first method nearly as much as you would have. Okay? So, what am I talking about and what are our goals? I want to show you what your goal is. Do not write anything down. I just want you to look. By the end of today's lesson, you will be able to graph an equation like this by doing this, this, and then drawing a graph. So, let me show you the difference. Here's the warm-up. Here's what you had to do this graph. Guess what? There was another way to do this. And in fact, I actually showed you how to do it on here. If you can find this point and you can find that point, you can draw a line through them and get the graph. And that's what you're going to learn how to do today. And that's what is outlined here. So by the end of today, you will have digested and understood how to do the second method. So, let's jump in. Here is a graph. There are 2 locations on the graph that are extra important. They are called the x-intercept and the y-intercept. The x-intercept and the y-intercept. And if you think about the terms, they tell you what it means. The x-intercept is the location on the graph where the graph crosses the x-axis. Let me pause for a second, because I say the word graph and I'm not sure if you know what I mean. This is the graph. What is this? And all this, and all this, and all this. What's that part in blue? What's that called? Paige? The coordinate grid. That's the grid. What's highlighted in yellow is the graph. So let's make sure we understand that distinction. So, what I'm saying is, the x-intercept is the point on the graph where it crosses the x-axis, which is right there. That's called the x-intercept. Let's look at its coordinates. I want you to think about what the coordinates are of that. What do I mean by coordinates? I would like you to find those coordinates, lock them into your brain. Do that right now. It should take you 5 seconds. Give me a thumbs up if you got the coordinates. Good, Amani, what are the coordinates?
2 and 5.
I'm not sure what you're looking at. We're looking right here.
Oh, sorry. It's
1, 0. The coordinates of the x-axis, the x-intercept are 1, 0. So you could say that the x-intercept was at 1, 0, or you can just say that the x-intercept is 1. You can say either one. I don't care. This demonstrates a higher understanding, but both are acceptable. What about the y-intercept? Well, I have the definition here. The y-intercept is the y-coordinate of the point where a graph crosses the y-axis. That sounds really fancy. But what it means is the point where the graph crosses the y-axis right there. So what I would like you to do is look at the graph, and I would like you to figure out what the coordinates are of that point, lock them into your brain. Give me a thumbs up when you got it. Laurel, what is it? Very good. 0, 3. So I want you to notice something. The x-intercept has a 0 for the y, and the y-intercept has a 0 for the x. And that will actually be true for any x-intercept or y-intercept. So, that's what they are. Oh, and I'm sorry, the y-intercept could also be written as y-intercept is 3. Either way. So, we now know x-intercept and the y-intercept. I already showed you what our goal was. This is our goal, to be able to do all of this. This is going to be maybe 20 minutes, 25 minutes from now. We're going to build to it. But I've also outlined for you what it is. So here it is. It's called graphing using intercepts, and it's the second method. The first method was making a table. So step 1, find the x-intercept. Step 2, find the y-intercept. Step 3, plot those 2 points and draw a line through them, and now you got the graph. It's a pretty simple set of steps. Find the x-intercept, find the y-intercept, plot the points, draw a line. I also have told you here in words how to do steps 1 and 2. To find the x-intercept, make y 0. To find the y-intercept, make x 0. We're going to talk more about that in about 20 minutes. Actually, in about 10 minutes, I should say. Any questions so far? Good. So let's first get a deeper understanding of this. Looking at a graph and finding the intercepts. So, example 1, we're going to go pretty quickly. I do not want you to draw the graphs. I want you to write example 1, find the x and y intercepts, and then write part A. And let's actually get rid of this for a minute, so we don't focus on it. And let's just focus on that. So just looking at the graph, you should easily be able to pick out the x and y intercepts. You should be able to look and just know. Because you're looking at 2 specific locations. You are looking here and here. And so, what is the x-intercept? And what is the y-intercept? That is what we're being asked, to find those. So what's the x-intercept? Kaylee? Very good. That's pretty high level. 3, 0, or you can just say 3. What about the y-intercept? What's the y-intercept? Amir?
0, -4.
0, it's a little bit hard to see from the back. I know it's a little small. It's not -4. It's -3. But I know it was hard to see. So you can either say 0, -3, or you can just say -3. Either way, it's totally fine. Any questions about finding x and y intercepts from a graph? Tristan? There's always going to be a 0 in the y position when you're finding the x-intercept, and there's always going to be a 0 in the x position when you're finding the y-intercept, and that's actually going to be really important in a few minutes. All right, so let's look at part B quickly, and I'm going to do this one a little bit differently. Now I want you to look at the graph, and I want you to lock in what you think the x-intercept and the y-intercept are. Give me a thumbs up if you got them. Okay, still need a moment. Okay, Adriana, what's the x-intercept?
-1.
It's -1. Or you could say -1 comma 0. What's the y-intercept, Amani? -2. Or you can say 0 comma -2. Either way. Anyone have any questions? So the last two, we're not going to actually actively do anything. I just want to show you that the pattern of the zeros continues. And then I have a real world example over here that I want to talk about. But if you look here, the x-intercept is at -2 comma 0. -2 comma 0. And the y-intercept is at 0 comma 4. So the zeros keep happening. So no matter what, if it's an x-intercept, it's going to have a 0 in the y position. And if it's a y-intercept, it's going to have a 0 in the x position. Any questions about that? Okay, so now let's look at part D, this real-world scenario. This is a real graph. This is actually the this is the distance left when taking a trip to Orlando. The distance left taking a trip to Orlando. So, you leave from home, you arrive in Orlando. Okay? So what are the intercepts for this? You able to see them? What are the intercepts? Chanel, what's the x-intercept? Yeah, it's 3 comma 0 right there. 3 comma 0, but this one's a little bit different because the 3 means hours and the 0 means miles or distance. So 3 hours, 0 miles left. What about the y-intercept up here? What's its coordinates? Alex?
6, 0.
Where'd you get 6 from? No, I'm trying to understand. Where'd you get the 6 from? Oh, you counted. Okay, but this isn't a 6. This is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So you can't say 6 because this number is what it actually represents. So instead of 6, you would say, okay, but you also put them in the wrong position. This is a y-intercept. How far did you go to the right or to the left? 0. 0 comma 120. But again, this has meaning. 0 hours, 120 miles. So the intercepts have important extra meaning. The intercepts here, the x-intercept tells you how much time has elapsed when there's no distance left. And the y-intercept tells you how many hours have elapsed when there's 120 miles that you still have to go. Okay? Any questions about that? So now, are there no questions? All right, so let's see how we do on our own. I lied. Let me go back. I thought we did. Sorry about that. So now, let's look at the x-intercept. X-intercept, number comma 0, number comma 0, number comma 0, and then down here, number comma 0. An x-intercept, there's always a 0 in the y position, always. So that actually tells us what to do to find it if we don't have a graph, if we have an equation. Yes?
For the real world one, you labeled the coordinates, so do we have to add 0 so we can rule it?
Do you have to add the 0?
Yeah, because like you said, if we just say 3.
Oh, but since it's real world, do you need to say 0 miles? Kind of depends on the question. If you just ask for the x-intercept, you can say 3. I'm okay with that. It's a good question, though. So now, I apologize for confusing you about doing a checkpoint. We don't need it. That's why I left it out. So now here's the real work. how do we find an x and y intercept if we don't have a graph? This is what we really want to learn how to do. Now, if I really wanted to, we could sit here for 10 minutes, draw a table, pick points, put the numbers in, get the outputs, put the points in, and draw a line, and then look at where it crosses. We could do that. But that would take 10 minutes, and we can accomplish the same goal in about 2 minutes. Now, the first time, it's going to take us a little bit longer because I go a little bit slower, but by the end of today, it should take you 2 minutes or less to find the x and y intercept. So let's go ahead and jump in. We want to get the x and y intercepts of that equation. So we're going to do the work separately. We're going to do the x-intercept first, and then we will come over here and do the y-intercept. So let me go back to what I wrote here in the notes. To find the x-intercept, let y equal 0. Let y equal 0 to find the x. Let's look at that again because I just went over why to do that. What is y equal to every time we get the x-intercept? Y is always a 0. So now we're working in reverse. Now we're going to make this 0, and then we'll find the x. So that's what we do. So watch what we do. X-intercept, we're going to take this and we're going to replace the y with 0. Negative 3x plus 4 times 0 equals 12. That's what I mean by make the y 0. I just made the y 0. How did I know to do that? I told you to. But I did it based on evidence. Every time I find the x-intercept, y is always 0. So let me now use that to find it. Make y 0, that will tell me the x. So now solve the equation. But before you do, my super high level students should already notice something. What do you notice about this right here? What's going to happen to that? What's going to happen to that? Kaylee?
If you multiply the 4 by the 0, make it 0.
Yeah, and 0 in math means just disappears, right? So the equation is really this, right? How many steps will that take? Hold up the number of fingers for how many steps that's going to take. How many steps is it going to take? Yeah, that's one step. Go ahead and do it. You should be Yoda of that. So what does x equal? What does x equal? Gary?
-4.
Amani, do you agree with that? Yeah, it's -4. Guess what? We just found the x-intercept. We just found it. If you're super advanced, you could say -4, 0, but I'll accept either one. Any questions about what we did? So now let's do the y-intercept. To find the y-intercept, make the x 0. So here's what it looks like. -3 times 0 plus 4 times y equals 12. But, Kaylee, you just told us a moment ago, what happens to this right here? Yeah, it just disappears. I love the way you said that. Just disappears. Give me a thumbs up if you could do that mentally. You should be able to. Michael, what does it equal? Y equals 3. The y-intercept is 3. Or if you're super fancy, you could say 0, 3, but I'll accept either way. Any questions about what we just did? So this is something you have to remember. You have to actively know in your mind that to find the x-intercept, you do that. To find the y-intercept, you do that. You have to remember. So it has to become part of you. And to do that requires practice. Any questions about that? Okay? So Part B. Just to make sure we're getting practice and we're understanding and we're moving forward, let's do it again. But this time, we're going to go faster. No need to go slow. X-intercept we're going to find, and then we're going to find the y-intercept. And could someone remind us, to find the x-intercept, what action do I take? What do I do? Chanel? Turn the y into a 0. So we're going to do that. 2x minus 0 equals 4. You'll start seeing a pattern here. Same things happening over and over again. So what's x equal to? Paige?
2.
X equals 2. The x-intercept is 2. If you're super fancy, you will say 2 comma 0, or say 2. The y-intercept. How do we find the y-intercept? What action must we take? What action? You can read from your notes if you need to. Excuse me. You dead? So we replace the x with a 0, but he already noticed that the 2x will become a 0. But just to make sure we're clear, it's this, but this disappears. And so we're left with negative y equals 4. So is that it? Negative, is that the y-intercept is 4?
No.
We have some disagreement. Caleb?
Y-intercept is -4.
-4? Michael, do you agree with that? How do you get that?
Negative.
Michael, how do you get that? Okay, Kayla, how do we get that?
Negative y is what is the opposite of y?
That's right. So the opposite of y is 4, so that means y must be -4. Another teacher in the school has a silly little saying she just says, flip it like a pancake, and what she means by that is you have to flip both sides. You flip it and flip it. Flip it like a pancake, and you end up with y equals -4. Or, if you're super advanced, you'll say 0 comma -4. Either way is acceptable. Any questions about that? Okay, let's pull something from last time. Could someone tell us what form of an equation is that? What form is it in? Oh, we have a whole bunch of people who know. Catalina? You agree with that, David? What was it again? That is standard form. Guess what? Finding intercepts when an equation is in standard form is super, super easy because of what Kaylee and Yadesh have pointed out. These things just turn into zeros and it becomes a one-step equation every time. But what happens if it's not in standard form? Let's see. Part C, y equals 1/3 x minus 2. I wonder if we can still do it. Let's try. Find the x-intercept. What do we do to find the x-intercept? What action must we take? Tristan?
We have to go to
Not the y-intercept, no. You do, but that's not what you said. You said the y-intercept. I know it's what you meant, but you got to be clear because you might have gotten fired from your job. So we make the y 0 equals 1/3 x minus 2. Can we solve that? Give me a thumbs up if you think you can solve that. I'll give you a hint. Put your thumb up. Of course you can solve it. Now put up the number of fingers to represent how many steps it's going to take. Yeah, it's 2 steps. Of course it's a 2-step equation. You're Yoda of 2-step equations. Super easy. Add 2 to both sides. You've mastered this from 2 months ago. Add 2 to both sides. That disappears. And we end up with 2 equals 1/3 x. What do we do with that? I don't know how to do that, and I'm scared. A fraction on Halloween, Mr. Gallant, you're terrible. How do we do it? How do we deal with that 1/3, David? Change the 2 into what? Okay, but that still won't get rid of the 1/3. So I'm going to tag team K-Shapay. Yeah, multiply both sides by 3. Multiply by the reciprocal. So 2 over 1, you didn't even really need to do that. It was a good try. That cancels that, and we get x equals 6. So the x-intercept is 6 or 6 comma 0. So when it was in standard form, it took 1 step, 1 step. When it was in this form, it took 2 steps, but you still were able to do it. But now let's look at the y-intercept. And to find the y-intercept, what action must we take? What action must we take, Yasmin? Beautifully said. Change the x to 0. Watch this. Y equals 1/3 times 0 minus 2. How many steps is that going to take? Hold up the number of fingers that it's going to take. The number of fingers. Good. Some of you are catching on. Yeah, it's going to be 0 steps. This will disappear, and it's just a -2. Y equals -2. So, finding the intercepts. Watch this. I just went x-intercept, x-intercept. So this one took 1 step, this one took 1 step, this one took 2 steps. But now look at it all together. Altogether, that was a total of 2 steps. Altogether, this was a total of 2 steps. Altogether, this was 2 steps, this was 0 steps. Altogether, it was still 2 steps. So even though it works out really nicely when it's in standard form, it's not really a big deal when it's in another form. Any questions about what we did? So, yes?
First, can you flip it around with, like, if you could y where the 2 is?
Yep, if you want to rearrange it first, absolutely. You could subtract y from both sides. That disappears, and you get 0 equals 1/3 x minus y minus 2. And then add 2 to both sides, and you get the 2 over there. Absolutely. But that might cause a little extra work, but if it makes you more comfortable, absolutely go ahead. Any questions? Any other questions? Okay, so now checkpoint. Sorry, I messed up a little bit. Checkpoint number 1, find the x and y intercept of the graph of that equation. You've got 2 minutes. see how we did. Look at the number on your desk and make sure you remember what desk you're sitting at. And I've got number 9 and number 20. Number 9. Number 9, what did you get? Okay, and number 20, what did you get?
The x-intercept -5 and 0 and the y-intercept 0 and -2.
Is that what you?
-5 and -2.
Is that what you said? Is that the same thing that you said? X-intercept is -5. Y-intercept is -2. Anyone have any? Well, let me survey first. Give me a thumbs up if you got it correct. Good. Put your thumbs down. Any comments or questions? Anyone know what we're going to do next? Think about it for a moment. So, I already showed you what we were going to do. I showed you this. Well, guess what you already know how to do? You already know how to do step 1. You already know how to do step 2. Guess what? You already know how to do step 3 also. So now it's just a matter of putting it all together. So, example 3, got 2 parts. Part A, we're going to graph this equation. 3x minus 7.5 equals negative 2.5y. So the goal is the graph. The goal is not the intercepts, the goal is the graph. But the intercepts is the work to get the graph. And it's much more efficient than making a table. So I'm calling it step 1 and step 2, but we're going to do that the first time. After that, you don't need to do that. Step 1, find the x-intercept. Well, you've done it 4 times already. This is going to be your 5th time. Step 2, find the y-intercept. You've done that 4 times. This is going to be the 5th time. Let's go ahead and do it. To find the x-intercept, what action must we take? Gary?
You must, you make y 0.
Good. And my advanced students should have noticed a pattern already. Yadesh really noticed it. What's going to happen over here, Yadesh? The whole thing becomes a 0. We plug a 0 right here. You multiply by 0, it becomes a 0. It's a simple 2-step equation. Go ahead and solve it. You can do it. You don't need me. You guys are all Grandmaster Yodas of solving 2-step equations. Go ahead. We'll work simultaneously. You do it and I'll do it. We'll see if we both get it right. What's the x-intercept? Amir, what'd you get?
2.5.
David, you agree? It is 2.5. Very good. The x-intercept is 2.5 or 2.5 comma 0. Any questions about that?
No, not about this.
Okay. Well, about something else? Go ahead.
It was actually, I got them as the same, like y's intercept is the same as x.
Well, let's find out. And it could happen.
Like not like,
Hold up.
It's 0, 2.5 and 2.5, 0.
Let's find out. So let's see. Now we'll find the y-intercept. What action must we take to find the y-intercept? Alex? Make the x a 0. And so when I plug in a 0 right here, what happens to this whole expression? Basically disappears. But does the negative disappear? No, because the negative goes with that. So we get negative 7.5 equals negative 2.5. How many steps will that take? That's just one. It's just a simple one-step equation. Divide by negative 2.5, divide by negative 2.5, and Gary is going to realize his mistake in about... Y equals what? Amari? Oh.
No, I did it wrong then, because I didn't have a negative 2.5.
Why not? It says negative 2.5 right there.
Oh, I wrote wrong.
Okay, so you just wrote it wrong. So it's really y equals positive 3,
I
of
did write
course.
it wrong.
Positive 3.
I still got that part.
So you tried to do mental math and you messed up. All right, so we get the x-intercept, we get the y-intercept. So we already did that. That's the 5th time you've done that. But now we're going to actually use it for what it's really for, which is to graph. So now everyone use your graph paper, and you can make a grid that's about 5 squares in each direction. That should be enough. Doesn't need to be huge this time. And we're going to go ahead and graph. The x-intercept will be 2.5. So go 1, 2, and then try to get as accurately as you can. 2.5 is going to be right in between the 2 and the 3, and I think I can do a little bit better. And then on the y-axis, we're going to go to 3 and put a dot. And now we draw a line. Use your ruler, hold the ruler across these 2 points, a little bit below the points, so when you draw the line, it goes through them. And draw the line. Make sure your line goes all the way through from one side of the grid to the other. And then make sure you put arrows on either end. That is not optional. And now we have a graph. Does anyone have any questions on the process we went through? So now I want you to compare what you just did to the warm-up. Look at this and look at the warm-up. Compare the work that you did. Which method seems more efficient to you at this point? Using intercepts or making the table? Which method seems more efficient to you? Think about it. And then volunteer a thought. It's an opinion question. There's no wrong answer. Yudesh? Intercept seems more efficient to you, Michael? Intercept seems more efficient, Alex? Amani? Gary? Yeah, I mean, and if you said table of values, it's totally fine if that's your comfort level. But usually intercepts will be much faster. Usually it will be much faster. Does anyone have any questions about that? Okay, well, we were going to do another example, but I think I'd rather just jump to the checkpoint, and I'd like you to work on it on your own and see how you do. So I would like you to graph this equation, and I will say this. Use either method. Use a table of values or use intercepts. Use intercepts. All right, so I used to give you like 5 minutes to make a table of values. Let's say 3 minutes and see how we do. Let's see how you do. Go. see some people still working. If you're already done, and someone else on your team is also done, compare your results. If you're still working, you got 1 more minute to try and finish your graph. Should be pretty close to being done, if not already done. Alright, put your pencils down. Here is the graph you should have gotten. It was a little bit more challenging to graph. I was able to use the computer software to go by 1s. You might have gone by 2s or something like that. So it crosses the y-axis at 20, the x-axis at 9, plot the points, draw the line. You can go by anything as long as it makes sense and you're able to graph it. The only issue I have with going by 5s is that 9 ends up being, a little bit of a challenge. It's not a big deal, but, because it's going to be so close to the 10 and it's not quite on the 10. But you probably have the same graph, except it looks a little bit smaller this way. Okay? Anyone have any comments, questions? Give me a thumbs up if you were successful. Good. I'm very proud of the work you guys have done. Put your thumbs down. Let's draw a line across our paper and your homework. So the line indicates that we're done with today's lesson and we're moving to the homework part. And that corresponds to the slip that I give you every day. So again, I apologize if this word points is confusing you. The points just refers to the fact that, this is 7 points because one of these questions, I think number 6, has 2 parts to it. So I'm counting each part separately, so I'm saying that that's 2 points. So it's a total of 13 points. We're supposed to have a quiz soon, but next week is kind of messed up. We've got, you guys are off on Tuesday for Election Day, and Thursday we're going to JA, so we got 2 days that are going to be interruptions. If I can fit a quiz in, next Friday, I might do that, but, I will certainly give you notice. It won't be a surprise or anything like that.